Good day, geometry. We are going to be taking the Pythagorean theorem to the next level in CO40 today, because yesterday we learned about how the Pythagorean theorem can be used for right triangles only to find missing side if you know two of them. So we wrote these theorems down yesterday, at least the original theorem, and essentially it says this: if c squared equals a squared plus b squared, then the triangle is a right triangle. Okay. If c squared is equal to a squared plus b squared, I told you I'd explain today why I put the c squared first rather than at the end of it. Just wait, the brilliance is coming here. Then we know the triangle is a right triangle. The converse of that, as we know about the converse of anything, would say what? Kind of the opposite. What do you mean by that, Drake?
It's the converse.
The converse, yes. Which means that in our if-then statements.
Oh, I mean, if this, then that.
So if this, then that is kind of the original statement. The converse would be if that, then this. It essentially works the other way too. So the converse would be if a triangle is a right triangle, then c squared equals a squared plus b squared. And I put that on there only because if we have the Pythagorean theorem, a converse does exist. So when we have our next postulate theorem quiz, both of those are going to be valid for it. Okay. Do we have the notes? Good? Okay, so what happens if c squared is not equal to a squared plus b squared? What if c squared is greater than a squared plus b squared? If c squared is greater than a squared plus b squared, we know it's not a right triangle. It's going to be an obtuse triangle. Exactly. If c squared equals a squared plus b squared, then the triangle is obtuse. So the Pythagorean theorem can be used for more than just solving for sides and right triangles. It can tell you what type of triangle you have if you know what all three of the sides are. If you have an obtuse triangle and you only know two of the sides, you can't use this to find the third. It only works in a right triangle to find the third. But if you know what all three are, you can then determine what type of triangle you have. Anyone wager a guess as to what theorem 7.4 is going to say? Joey?
If c squared is less than a plus b squared, a squared plus b squared, then it's acute.
Yes. If c squared is less than a squared plus b squared, then the triangle is acute. If c squared is less than a squared plus b squared, then the triangle is acute. So why put that c squared value first? Okay, you don't have to write this down on your page if you think it's going to ultimately confuse you, but just the method to the madness here, putting our c squared on the right side of our inequality symbol rather than the left, how would it change that? How would we have to write this if we want to put the c squared on the right side? What would change? James?
Then a squared plus b squared would be greater than?
Right. If c squared is less than a squared plus b squared for a acute triangle, that would mean that a squared plus b squared would have to be greater than c squared. Can you see the confusion in the greater than symbol and the acuteness of the triangle here, written with c squared on the right side? Okay. Likewise, for this one here, if we were to write the c squared on the right side, it would flip everything. It would be a squared plus b squared is less than c squared for an obtuse triangle. So the reason why we put the c squared on the left side is to get that direct relationship: less than acute, less than 90 degrees, greater than obtuse, greater than 90 degrees. Okay, so that's the reason why. It makes that relationship of less than acuteness greater than an obtusity more clear. Okay? How do you know which values to use for A, B, and C? And really the important one here is the C. How, if it's not a right triangle, how would you know, or does it not make a difference, which values you would use for A, B, and C? Drew?
C always have to be the greatest.
Still, C will still have to be the longest side. A and B, you can switch them up. But even though it's not called the hypotenuse, because it's not a right triangle, your C value would still be the longest side. Okay? And since you know what all three sides are, then you can easily tell, or you can figure out how to tell which side is the longest. All right. Questions on this so far? We feel like we have the relationships. Okay, let's practice then. I've got 3 sets down here. So do the segments form a triangle? If so, is it acute, right, or obtuse? Show your work. 10, 11, 14. First things first, will these 3 sides even make a triangle? Yes, and we know that because 10 plus 11, the 2 shorter sides, add to be greater than the third side. That's the A plus B has to be greater than C, the triangle inequality theorem. That is true here. We know that C is 14 because it's the longest side. Beyond that, A and B doesn't matter which one is which. We might as well just go A, B, C. Okay? So to set this up, we're looking for the relationship of C squared compared to A squared plus B squared. Right now, we don't know. We can't put a symbol in there because we don't know what the relationship is. Is 14 squared going to be equal to 10 squared plus 11 squared? Will it be greater than, less than? We don't know. So we're kind of figuring this out here. Okay? And then on the other side of that is going to be 10 squared plus 11 squared. And I might as well write my 14 squared in now. So 14 squared is 196. We still don't know what's going to happen here. 10 squared is 100. 11 squared is 121. And simplifying it further, 196 compared to 221. So what symbol is going to go inside the box? William? Less than. Which means, what type of triangle is 10, 11, and 14? Acute. Exactly. Okay? You okay? So far so good? Okay. Let's look at the next one. 4, 4 root 3, and 8. What's the longest side of 4, 4 root 3, and 8? Blake? 8's the longest side. You could compute 4 times root 3 in your calculator. You'll get 7 point something or 6 point something. So 8's the longest side. So again, we're going to treat that as our C and these as A and B, and we're going to kind of explore. 8 squared is what compared to 4 squared plus 4 root 3 squared? Please note my use of parentheses. This is one of those situations where your calculator could be your worst enemy because of order of operations. If in your calculator to square this, you just put 4 root 3 squared, what's your calculator going to square? The root 3 and the root 3 only. It's going to ignore the 4. Okay? So to do this correctly, you need parentheses around the 4 root 3 so it squares the entire thing. Squares the entire thing. 8 squared is 64. Still don't know what's going to go in there. 4 squared is 16. And what does 4 root 3 squared end up being? Caleb?
48.
48? How is that work?
12. Whoops, I did mine wrong. Whoops.
No, you didn't do yours wrong. 48 is the correct answer. You need parentheses around the 4 root 3. Remember, when you push the root symbol, it gives you a parenthesis automatically. So really, what your calculation should look like is this. You need to add your own set. Okay?
I just assumed I did it wrong.
If you do not put a parenthesis around that 4 and include it as part of the base, your calculator is going to be your worst enemy. It's only going to square the 3. Since it gives you a parenthesis with the root anyway, you've got to add your own set. So I didn't make that very clear here, but you do need that parenthesis around the 4.
Caleb was right.
Caleb is correct. Why is Caleb right? Why is 48? Why does it make sense now that you think about it?
It doesn't.
It does. Well, it will then.
No.
Okay? If we're squaring 4 root 3, that means we're squaring 4. What's 4 squared? 16. What's root 3 squared? The root of 9, which equals 3. And 16 times 3 is 48. Okay? Be very careful about that. Right? You've got to put that in parentheses, or it's only going to square the root and it's going to run into problems. So in this case, 16 plus 48 equals 64. So what symbol goes in the box? Equals. Good. So what type of triangle do we have? A right triangle. Because c squared is equal to a squared plus b squared. Is anyone still kind of confused about the whole parenthesis deal with 4 and 3? Basically, you've got to add your own set, okay? Because it gives you one automatically when you push the root symbol. So you've got to put one in front of the 4 and on the back end. So you have 2 sets total there, okay? Last one, 5, 6, and root 61. What's the longest side here, Peter? It's the root 61. So we are going to label that our C. And A and B. The root of 61 squared is what? So 5 squared plus 6 squared. The root of 61 squared equals what? 61. The root and the power just cancel out, right? There's no coefficient to worry about here, so we don't have to be quite as careful as we did in the last one. But 61 squared, root 61 squared is 61. We're comparing that with 25 plus 36. Well, this is curious. I wonder why I did that. You'd think I would make one acute, one right, and one obtuse, but I guess I still surprised myself. 61 is equal to 61, therefore this is, again, a right triangle. Okay. Questions on CO40?
No.
Joe, can you turn around, please? I don't like to have to stop class to ask you to turn around.
He's running out of words.
I still have enough time to assign you homework, which is fantastic.
Wow.
So, what's your question? Why do I hate
Sure, you go. Sure.
On page 444.
Just give us like 3 to 4. Just give us like 5 questions.
Now I gotta read on that book.
Don't ask me for little questions.
You could write all the questions down first and then just take that. Let's do 16 through 22. I want to see your work. 7 questions. That's it.
What if I do fake work?
Fake work? If you put the time into fake work, why don't you do real work? Like,
Okay,
I'm just, you know.
I just write random numbers down.
Okay.
I just write random numbers down.
Thanks, folks. Have a good day. At that time, Matt, like and subscribe. All the things.
Don't like